A compound inequality is a statement in which two inequalities are connected by the word and or the word or. So a conjunction is when we have the word and. 2x plus 5 is greater than or equal to -9. And 2x plus 5 is less than 25. A disjunction would represent the or statements. These are completely separate from each other. So x minus 3 is greater than 5, or x plus 4 is less than or equal to -2. So we're first going to discuss conjunctions. When we're solving for a specific variable in a conjunction, you solve for it the same way we just solved for a regular inequality. You first remove the constant, but you do so from all three terms in the compound. So in this example, we have -9 is less than or equal to 2x plus 5, which is less than 25. So if we're solving for x, step 1 is going to be to remove the constant, +5, by subtracting 5 from all three terms. We subtract 5 here. We need to subtract 5 from all parts of the inequality to keep it balanced, leaving us with -9 minus 5, which is -14 on the left side. The symbol remains the same, which is less than or equal to 2x. And on the right side, 25 minus 5 leaves us with 20. The second step is to remove the coefficient the way we normally would. So step 2, we remove this coefficient by dividing all three terms by 2. When we do so, -14 divided by 2 leaves you with -7. 2x divided by 2 leaves you with x. 20 divided by 2 leaves you with 10. Since we're dividing by a positive number, the symbols remain the same. So the answer to this particular compound would be -7 is less than or equal to x, which is less than 10. Now, if you want to check the answer for a compound inequality, you need to check the way we did previously, except we need to do so twice. So here's what that would look like. -7 is less than or equal to x. So we can plug in -8 to prove that that doesn't work, and then -7 to prove that that does work, thus showing us that this end is true. So if we plug in -8 for x, that leaves us with 2 times -8, which is -16. -16 plus 5 is -11. And we see that this end is not true. -9 is not less than -11. So -8 does not work, which is what we were hoping for. If we switch -8 to -7, it should be able to equal -7 and give us a true statement. 2 times -7 is -14. -14 plus 5 is -9. And we wind up with -9 is less than or equal to -9, so that's true. And -9 is less than 25, that's true. So we see that this end of our compound is in fact correct. Now let's plug in 2 more numbers on this side to show that x is less than 10. If we plug in 9, that should work. And if we plug in 10, that should not work. When we plug in 9, 2 times 9 is 18. 18 plus 5 is 23. The first part is true. -9 is less than 23. The second part is true. 23 is less than 25. And then to prove that 10 is our limit, we plug in 10. 2 times 10 is 20. 20 plus 5 is 25. And we see that x cannot equal 10 because when it does, we get a false statement. 25 is not less than 25. So by checking, we confirm that this is in fact correct. -7 is less than or equal to x, which is less than 10. So that is how you would solve conjunctions. Let's have you do a few practice questions. Solve for x and check the answer. Question number 1, -2 is less than x plus 7, which is less than 5. Question number 2, -12 is less than or equal to 3x minus 6, which is less than or equal to 12. And then question number 3, 4 is less than negative 2x plus 4, which is less than or equal to 20. Pause the video, try these practice questions, and then press play when you are ready. Okay, question number 1. Negative 2 is less than x plus 7, which is less than 5. Step 1, remove the constant 7 by subtracting 7 from all three terms. When we do so, we wind up with negative 2 minus 7, which is negative 9, which is less than x, which is less than 5 minus 7, which is negative 2. So this is our answer. Negative 9 is less than x, which is less than negative 2. Step 2, check the answer by plugging 4 numbers into the original inequality. Negative 9 should not work. Negative 8 should work. When you plug in negative 9 for x, that leaves us with negative 9 plus 7, which is negative 2, leaving us with a false statement. Negative 2 is not less than negative 2. So negative 9 did not work, as we hoped it would not. When we plug in negative 8 plus 7, which is negative 1, leaving us with a true statement. Negative 2 is less than negative 1. Negative 1 is less than 5. So this end is correct. Negative 3 plus 7 is positive 4, leaving us with negative 2 is less than positive 4, which is true, and 4 is less than 5, which is also true. We then plug in negative 2. Negative 2 plus 7 is positive 5, leaving us with the false statement 5 is less than 5. So we see that this is the correct answer. Negative 9 is less than x, which is less than negative 2. Let's take a look at question number 2. Negative 12 is less than or equal to 3x minus 6, which is less than or equal to 12. Step 1, remove the constant negative 6 by adding 6 to all three terms. When we do so, we wind up with negative 12 plus 6 is equal to negative 6. 3x is in the middle, and 12 plus 6 is 18. So we have negative 6 is less than or equal to 3x, which is less than or equal to 18. Step 2, remove the coefficient 3 by dividing all three terms by 3. Negative 6 divided by positive 3 is negative 2. 18 divided by 3 is 6. Our signs remain the same. So the answer is negative 2 is less than or equal to x, which is less than or equal to positive 6. Step 3, check the answer by plugging 4 numbers into the original inequality. So when we plug in negative 3, 3 times negative 3 is negative 9. Negative 9 minus 6 is negative 15. And as we hoped, we wind up with a false statement. Negative 12 is not less than negative 15. If we plug in negative 2, we're hoping that we wind up with a true statement, since negative 2 can equal x. 3 times negative 2 is negative 6. Negative 6 minus 6 is negative 12. And we wind up with a true statement. Negative 12 is less than or equal to negative 12. They're equal, so that works. Negative 12 is less than 12. So this, negative 12 is less than or equal to 12, also works. So we have x is less than or equal to 6. So we should try 6, which should work. And we should try 7, which should not work. So when we plug in 6 for x, that leaves us with 3 times 6, which is 18. 18 minus 6 is 12. And as we had hoped for, we wind up with a true statement. Negative 12 is less than or equal to 12, which is less than or equal to 12. So that's true. And now we plug in 7 for x. 3 times 7 is 21. 21 minus 6 is 15. And we wind up with a false statement here because 15 is not less than 12. So the answer to question number 2 is negative 2 is less than or equal to x, which is less than or equal to 6. Question number 3. 4 is less than negative 2x plus 4, which is less than or equal to 20. Step 1, remove the constant by subtracting 4 from all three terms. When we do so, 4 minus 4 is 0. 20 minus 4 is 16. Step 2, remove the coefficient by dividing all three terms by negative 2. 0 divided by negative 2 is 0. 16 divided by negative 2 is negative 8. And since we are dividing by a negative number, we need to reverse the less than and less than or equal to symbols to greater than and greater than or equal to symbols. So if we reverse this, we get negative 8 is less than or equal to x, which is less than 0. Step 3, check the answer by plugging 4 numbers into the original inequality. So since we have negative 8 is less than or equal to x, we want to test a value that is too small, which would be negative 9. That should not work. We then want to test negative 8, since x can equal negative 8, and that should work. When you plug in negative 9 for x, that leaves us with negative 2 times negative 9 is 18. 18 plus 4 is 22, and 22 is not less than 20. When we plug in negative 8 instead, negative 2 times negative 8 is 16. 16 plus 4 is 20, and that leaves us with a true statement. 4 is less than 20, which is less than or equal to 20. Negative 8 is less than or equal to x is the correct answer on this side of our inequality. Now we want to test the right side of our inequality. X is less than 0. So we want to plug in a number that is less than 0, like negative 1. That should work. And then if you plug in 0, that should not work, since x should be less than 0. Negative 2 times negative 1 is 2. 2 plus 4 is 6, leaving us with a true statement. 4 is less than 6, which is less than or equal to 20. And now if we plug in 0 for x, that should leave us with a false statement. Since x cannot equal 0, it must be less than 0. Negative 2 times 0 is 0. 0 plus 4 is 4, leaving us with the false statement, 4 is less than 4. That proves that the right side of this inequality is true, showing that the correct answer to question number 3 is negative 8 is less than or equal to x, which is less than 0.